The James Webb Telescope has made a discovery that is generating quite a stir at NASA. It seems to have provided us with an intriguing idea about the existence of a multiverse, or even the possibility of parallel universes. Is it possible for parallel universes to exist? Our current understanding of how our universe originated suggests that there are numerous additional universes, which supports the multiverse theory. In fact, it is very likely that there are an infinite number of them. If you're interested in keeping up to date with news from the universe and its surroundings, subscribe to our channel. Be sure to like this video and turn on the notification bell. This exciting discovery has aroused great excitement and is challenging the theories we have known for years. But what has it caused such a stir and shaking the traditional ideas? The reason lies in the big question it raises: what is the multiverse really like? It is curious that some people even speculate that in one of these parallel universes there is another version of you, as if there were a kind of alternative soul. This other version of you could be waiting for the chance to meet you, like a cosmic twin. If we consider the existence of multiple universes, the interesting idea arises that gravity may transcend from one universe to another, being perceived by other universes adjacent to ours. In other words, the gravity we experience in our own universe could be interpreted as ordinary gravity in a parallel universe, thus explaining the places where we perceive additional gravity. The multiverse concept has become the new trend, capturing the imagination of scientists and space enthusiasts alike. Now, the exciting part is, can we enter the universe and meet our cosmic twin? Herein lies the dilemma of entering the multiverse. Have you ever wondered what lies beyond the farthest reaches of the universe that we can observe? Could it be that our universe is just one small piece of a larger puzzle called the multiverse? Even movies enjoy exploring these fascinating questions, from stories like Everything Everywhere at Once to exciting superhero adventures like Doctor Strange in the Multiverse of Madness. Science fiction narratives dive into the creative possibilities of alternative realities. But here's the interesting part. Some scientists argue that the notion of a multiverse goes beyond simply being a fantasy or a narrative role. If the multiverse exists, it would imply the existence of other universes separate from our own, each with its own set of physical rules and laws. However, these universes are currently beyond our reach and cannot be directly measured. This raises a question of whether exploring the multiverse can be considered truly scientific. What exactly is a multiverse? Scientists use this term to describe the idea that there could be more than our observable universe. Various scientific theories propose different scenarios, such as the existence of other spatial regions on other planes, or separate bubble universes that continually emerge. Delving into the concept of the multiverse, one of the most widely accepted theories is the inflationary cosmology. This theory refers to the immediate aftermath after the Big Bang, where the universe experienced a rapid exponential expansion known as cosmic inflation. This idea helps explain many of the observations we make in the universe, such as its structure and the formation of galaxies. In its early days, this theory might have sounded like a page out of an exciting science fiction story, an extremely fanciful idea. However, it turned out that the theory of cosmic inflation surprisingly explained a wide range of fascinating phenomena in our world, which leads scientists to take it seriously. According to this theory, cosmic inflation would not have just occurred once, but on multiple, perhaps even infinite occasions, leading to the creation of a wide variety of bubble universes. The amazing thing is that not all of these universes would be identical to ours. They could have different properties and behave according to their own physical laws. Some might be even similar to our universe, while others might be completely different. However, all these bubble universes would exist beyond what we can directly observe. Another fascinating theory about the multiverse is a many worlds interpretation in the field of quantum mechanics. In 1957, physicist Hugh Everett proposed this theory, which mathematically describes how matter behaves. According to the many worlds interpretation, our universe is not alone, but suggests the existence of innumerable parallel Earths, each following its own timeline or set of events. These parallel realities are separated from each other, thus creating different outcomes and possibility. Imagine that every choice we make, whether big or small, can trigger a different outcome in a different reality. On one Earth, you might have decided to become an astronaut, while on another Earth, you might have pursued a career as an artist. These parallel versions of yourself would live different lives based on the choices they made. However, we are only aware of the reality we inhabit, unable to perceive or experience the other parallel Earths. According to the interpretation of many worlds, each reality is isolated from the others, giving rise to a multitude of possibilities and unique outcomes. You may wonder where these other Earths could exist. Space enthusiasts are alert to this idea of parallel Earths, which could be overlapping but invisible to us. Scientist Max Tegmark of MIT described this type of multiverse as a level 3 multiverse, where different scenarios play out simultaneously in branching realities. Imagine that in the interpretation of many worlds, each existing possibility is like an atomic bomb about to explode. However, in each branded reality, the timing of the explosion may vary. It is like having different timelines where events unfold differently. In some of those realities, that atomic bomb might not exist at all or pose any threat. On the other hand, there is another type of multiverse predicted by certain cosmic inflation theories, which Max Tegmark calls the level 2 multiverse. In this scenario, the fundamental laws of physics may vary in different universes. Each universe would have its own set of rules and properties. According to Linda physics, in an inflammatory universe, we cannot even be sure whether atomic bombs are possible in some parts of the universe. Although certain aspects of the universe suggest the need for multiverses, so far we have not directly observed any evidence to confirm their existence. Support for the idea of a multiverse comes from more theories and concepts than from concrete observations. Some experts raise the possibility that it is an amazing coincidence that the Big Bang gave rise to a universe perfectly suited for our existence. However, other scientists consider more likely the existence of numerous physical universes in which we inhabit one, with conditions conducive to the development of life. This idea of infinite small universes, often referred to as bubble universes, captures the imagination. These alternative universes could have different physics or different fundamental constants, which adds to the appeal of the multiverse concept. Some scientists take these ideas seriously as they help to address certain philosophical questions and challenges. However, debate arises as to whether it is possible to test the multiverse theory by empirical means. Some argue that, by definition, a multiverse is independent of our own universe and is inaccessible. This makes direct testing difficult. However, others believe that we may not yet have considered the right approach or experiment to unlock the secrets of the multiverse. Recent discoveries made by the James Webb Space Telescope raise intriguing questions about the possibility of a multiverse. Although concrete evidence remains scarce, these advances have sparked interest in exploring this fascinating idea. The detection of ancient galaxies and galaxies known as universe breakers challenges our current understanding of cosmology and galaxy formation. These objects turned out to be much larger and older than expected, raising the possibility of the existence of other universes or providing clues towards a multiverse. These ideas are supported by the renowned Stephen King, who once pondered the existence of baby universes. The notion of baby universes raises the question of whether we could inhabit a universe that resembles a black hole for those on the outside. Hawking introduced us to this idea, and this is where things get interesting. To simplify, black holes have a unique feature known as the event horizon, which is a boundary that produces different outcomes for objects inside and outside it. Inside the event horizon, objects are destined to be consumed by black holes due to the intense curvature of space and time. On the other hand, outside the event horizon, objects can escape the gravitational influence of the black hole if they have sufficient velocity or acceleration. Now, how does this relate to our universe? If we consider all known forms of matter and radiation in the observable universe, including normal matter, neutrinos, dark matter, photons, and gravitational waves, we can determine the equivalent mass of the universe using the famous Einstein equation. This leads us to explore the possibility that other regions or universes with different properties and conditions exist beyond our current scope. What do you think? Do you believe that the multiverse exists? Let us know in the comments box. Remember to like the video if you liked it and subscribe so you don't miss more content like this. Thank you so much for watching. See you soon.